Good morning, ma'am.
Yes, I'm starting the class. Good
Hello, ma'am.
afternoon to everyone. Okay, so in the last class, we were talking about method of variation of parameters, and we have seen how to solve a second order differential equation using this method of variation of parameters. So today, first I will consider one problem. Solve the equation d2y by dx2 plus a square y is equal to sec ax by the method of so first of all we solve the equation d2y by dx2 plus a square y is equal to 0. All of you know the solution of this. Can you
Yes,
tell
ma'am.
me what will be the yes?
C1 cos AX plus C2 sin AX, ma'am. T power
Yes.
0.
Uh, so solution of equation 2 is given by sin ax, where c1 and c2 are constants. Now let y is equal to, so here your u is equal to cos of ax and v is equal to sin ax. These are the two integral solutions of in equation 2. So the general solution is given by y is equal to c1 cos ax plus c2 sin ax. Let y is equal to a cos ax plus b sin ax be the solution of equation 1. Here in this equation 1, d2y dx2 plus py plus p dy dx plus qy is equal to r. So here p is equal to 0, q is equal to a square, and r is equal to sec ax. Where a and b are not constants, where A and B are not constants. Now we choose A and B such that and A1 U1 plus B1 V1 is equal to R. That means A1 cos AX equals to 0. And say this is your equation 3. And A1 U1 that is differentiation of cos of AX minus A sin AX plus B1 V1 that is equal to R. What is your R here? Take AX. This is your equation 4. Now here we can check the Wronskian determinant. What is the Wronskian determinant? W is equal to U V U1 V1. So that means A cos square AX plus A sin square AX. That is, this is equal to, so this is not equal to 0. Now we solve equations 3 and 4. That is, if we multiply equation 3 by sin AX and equation 4 by cos AX, so what you will get? A1 sin AX cos AX minus, you have to multiply by A sin AX A1 A sin AX cos AX minus A1 A sin AX cos AX plus B1 A sin square AX plus B1 A cos square AX. That is equal to sec AX sec AX into cos AX, that is 1 So B1 this implies so this is equal to
Ma'am, that should be a cos square ax. B1 into the previous
yes
step.
Yes,
a
please.
cos square
Cos
a.
square Ax.
Okay. Now putting the value of B1 in equation 3. So A1 cos AX A1 plus B1 means 1 by A. That is equal to 0. So A1 is equal to minus 1 by A tan AX. So that is A is equal to integrating so minus 1 by A this will be minus uh, log of
A square.
cos
1
of
by a square.
A square and sign will be positive. Yes, sign will be positive. So therefore, the general solution of equation 1 is AU plus BV x by A sin X. So this is the general solution. Now you can see that this contains this C2 cos AX and C1 sin X. That is, if you solve this equation, previously you have solved this equation, say, by finding the complementary function and the particular integral. So this is the complementary function and the particular integral. In some cases, it may be difficult to find. So you can apply the method of variation of parameters in those cases. Let us consider another example. So here I have solved the equations A1U plus B1V is equal to 0 and A1U1 plus B1V1 is equal to R. I told you in the previous class that you can either remember these two equations or you can directly write A is equal to integration minus r by w v dx, and v is r by w u dx. Here we had written a is minus r by w v dx. Let us solve this equation. d2y by dx2 1 plus e to the power of x. So we first solve the equation
P square minus 1 is equal to 0.
this equation d2y by dx2 minus y is equal to 0. So here the auxiliary equation will be m square minus 1 equals to 0. M is equal to plus minus 1. So therefore, solution of equation 2 is C1 e to the power of minus 6, where are arbitrary constants. Now, the Wronskian determinant. So here your u is equal to e to the power of x, v is equal to e to the power of minus x. So what will be the Wronskian determinant? E to the power of minus x.
e to the power x and minus
e to the power x minus e to the power minus x.
So we have this determinant. That is, when you evaluate this determinant, what you are getting? This is equal
Minus.
to
excuse me, ma'am.
Minus 2.
yes, minus 2. That is, this is not equal to 0.
Ma'am, I have
Yes,
a doubt.
yes. Tell me.
Ma'am, we have to express the general solution in terms of exponential form or trigonometric form depending upon the value of r.
Have you no?
No, depending upon the
Not on
homogeneous
the
form.
value of r. I think you forgot the previous things. That is when you are having a solution of the form. Please mute yourself. Yes, please mute yourself. What is this? Who is talking? Who is there? What is this? When I'm telling you something which you have forgotten, this was in your previous semester. Why all of you are talking at the same time? Please don't disturb the class. So, the solution of the complementary function it depends on this here you had d square minus 1 is equal to 0. So the auxiliary equation is m square minus that is the 2 roots of m are plus minus 1. So that is why when this is the form, then your solution will be these 2 roots are real and unequal. So your solution will be
So, ma'am, then it will be exponential form, right?
C1 equal
yes.
M1x. Yeah.
In the other case, a first problem,
Yes, when the
what was the
imaginary. Yes.
auxiliary equation was m square plus a square equals to 0. M is equal to plus minus IA. So that is why we had the solution in the form plus C2 sin X. Okay. So there
Yes,
are,
ma'am.
it depends on the value of M. If the 2 roots are equal, then what will be the solution?
C1 plus C2x into e per mx. Ma'am.
Yes.
Yes, ma'am.
Yes. So this is the concept.
Ma'am, so it basically depends upon the roots, whether they are equal or
Yes.
unequal or not.
Yes, it depends on the roots, whether they are equal, unequal, or real and imaginary, real and unequal, or imaginary.
Ma'am, m
Imaginary
square
roots. Yes.
ma'am, m square minus 1 will be equals to 0 there.
Yes, m square. M square minus 1 equals to 0. Okay. Now, let the general solution be of equation 1. Y is equal to plus BV, where A and B are not constants. Okay. Now here we have already found the Wronskian determinant. W is not equal to 0. So we write directly A and B are not constants. A and B are given by A is equal to minus R by W V dx plus C1. So what is our R here? 2 by 1 plus e to the
2
power
upon
of A. So therefore A is equal to divided by W. W is minus 2. 2 So you will have, this will be 1 into V. So that is e to the power of minus x dx divided by 1 plus e to the power of x. And our b will be equals to integration of r by w u so here you will have one minus sign, 2 by 1 plus e to the power of x, and w is minus 2. And e to the power of so we can integrate this directly and we get e to the power of x dx divided by this. That is minus now for a, one by e to the power of x. So we can write this as yes. So integrating the first one, e to the power of minus x dx. So minus e to the power of minus x. Now to integrate this,
You can add and subtract e power x now.
is equal to z. So e to the power of x dx will be equals to z dz. So dx will be equals to dz by z minus 1. dz by z minus 1. That is, you are having here minus integration plus some constant. So that is, this is equal to minus z minus 1 minus z. So this sign will be plus. So that is, we get minus e to the power of minus x plus log of z one plus e to the power of x minus log of z minus 1. That is log of e to the power of x. plus some constant.
ఇప్పుడు వరకే ఏదో ఒకటి పోద్ది మరి అయితే
What is happening here? Who is doing these things? So our general solution is given by y is equal to a or log of u plus bv. What is your b here? Minus log of, oh, both the constants I have written C2, no.
Ma'am, log of e to the power x will be x, na?
Yes.
So we can write that form.
No, log of e to the power of x will not be x.
ln e to the power x will be.
Yes.
We had to multiply with log e.
Ma'am, in the calculus, this should be base e. When log to the base e.
Yes. Let me first write the solution. Plus, this is C1 this is the general solution of equation 1. I think you are confusing with this. E to the power of log x. That is equal to x. And yes, log x log e. You can write this as x also, but here.
When base, yes, ma'am. That's what he was telling. That base should be
yes.
when we integrate.
Integration of dx by
base
x
is
equals
e.
to log x to the base e.
Yes,
Ma'am,
base e.
these are all ln x. Natural.
Okay. So I have done the solution either by this method or by that method. So you can choose any one. If you are asked to find the Wronskian determinant and show that the solutions, first you have to show that the solutions are linearly independent. Wronskian determinant is not equal to 0. That means what? U and V are
dependent on x.
No, linearly
they are not. Yes, ma'am. They are linearly independent.
Wronskian determinant is not equal to 0. That means the two solutions U and V given by e to the power of x and e to the power minus x are linearly independent. So we can write the solution of the equation in the general form of equation 2 as C1 e to the power. It is a linear combination of these two linearly independent solutions. Okay. Now next we will discuss about
Ma'am, what if W equal to 0?
Then the solutions are not linearly independent and the method is not applicable. Because here you are having A is equal to
And W is denominator. That's why.
denominator, W in the denominator, A by A is equal to and B is equal to R by W. So W is not equal. If W is equal to 0, then your solutions are not linearly independent. Okay. So you cannot find the general solution of equation 1.
Okay, ma'am.
Now let us come to this next chapter, that is simultaneous differential equations. When I had defined ordinary differential equations, what I have told you, I told you that in case of ordinary differential equations, the differential coefficients arise out of a function of the form y is equal to fx. That means one independent variable and one dependent variable. Now, when we have more than one dependent variables, and
Madam,
yes,
ma'am, I have a doubt in second order differential equations, ma'am.
tell me.
Ma'am, we are writing linearly independent solution, no, ma'am, in the
Yes,
beginning of the solution.
yes.
Ma'am, can you please tell how we are writing?
That I had explained in the last class with the theorem. That is linearly independent. Which solutions are linearly independent?
Yes, ma'am, for the particular
This
problem.
U and V are linearly independent. Why these are linearly independent? Can you write U in terms of V or V in terms of U? Can you express linearly independent means? You cannot write U in terms of V or V in terms of U. So that is why these are linearly independent. And the condition for which is the Wronskian determinant must be not equal to 0.
Yes, ma'am, we have written that y equal to c1 e power x and plus c2 e power minus x, ma'am.
Yes. So if these are linearly independent, then the general solution of equation 2 will be given by the linear combination. This is the linear combination of the two linearly independent integral solutions. Is it okay?
Yes, ma'am.
C1 e to the power of x, that is C1u plus C2v, where u and v are two linearly independent solutions. And you know that a general solution of a nth order differential equation must involve n arbitrary constants. So a second order differential equation, we are having two arbitrary constants. Is it okay?
Yes, ma'am.
Okay. Now, when we are having more than one dependent variables and one independent variable, the equations involving differential coefficients or derivatives of such functions are called simultaneous differential equations. And the number of equations will depend on the number of dependent variables. Is it clear? If there are more than one dependent variable and one independent variable, the equations involving derivatives of such functions are called simultaneous differential equations. And the number of equations, how many equations you will have, it will depend on the number of dependent variables. So let us consider the method of solution of simultaneous linear differential equations, first with constant coefficients. Okay. Solution of simultaneous differential equations with constant coefficients. Let us consider T be the independent variable and X and Y are two dependent variables. That is, say X is equal to some function of T y is equal to some function of T. So here, as there are two dependent variables, we will have two simultaneous number of equations will be 2. So let us consider f1 dx and phi 1 dx these are the two equations where f1d f2d are rational integral functions of d. And what is your capital D here? D is the operator given by d by dt. d by dt. So that means we are having two equations given by 1 and 2. So the first method is called the method of elimination. The first method, this is called the method of elimination. That is from equations we eliminate say x, any one variable, say x. Then we get a differential equation in y and t. We get a differential equation in y and t, which we can solve. So if we get our y, then from any one of the equations,
Ma'am, can you please show the previous slide for a second?
yes, then from any one of the equations, we get x. So that is,
Okay, ma'am.
we are discussing the method of elimination. So we eliminate any one variable, say x, from 1 and 2. So we will be left with a differential equation in y and t. So which we can solve for y. Then from any one of the equations, we get the solution for x. Let us consider a simple example.
Ma'am, that is minus 7x.
Yes, minus 7x. Dx by dt minus 7x plus y equals to 0, and dy by dt minus 2x minus 5y is equal to 0. So we write the equations equations 1 and 2 in symbolic form. So this will be d minus 7x where capital D is equal to your d by dt. Then second equation minus 2x plus d minus 5y. So this is our equation, say so in order to eliminate say x, we multiply equation 3 by 2 and we add with it equation 4 multiplied by d minus 7. So what we will get? We will get 2y d minus 5 into d minus 7y, that is equal to 0. So that means this equation becomes what? D squared minus 12d plus 37y. Now you can find the solution of this equation. This is your equation 5. So what will be the solution of this equation? That is m squared. Auxiliary equation is minus 12m plus 37 equals to 0. So m is equal to,
Ma'am?
yes,
Ma'am, that should be d square y minus 12 dy plus 37y equals to 0 na?
yes,
Yes.
Yes, ma'am.
the bracket was missing. Yes, you have rightly pointed out. Yes, d square minus 12d plus 37 operated on y. This is the operator fd. So m will be equals to 12 plus minus divided by 2. 12 by 2, that is 6 plus minus. From here you are having minus 4. So that means plus minus 2i. That is plus minus I divided by 2. So this will be 6 plus minus I. So therefore, the solution of equation 5, I marked this equation, yes, equation 5. Y is equal to, what will be the solution? E to the power of 6t C1 this is of the form alpha plus minus I beta. So that is the solution will be of the form e to the power of alpha t C1 cos of beta t plus C2 sin t. C1 and C2 are constants. Okay. Now we have to put this in any one of the given equations. Say equation 1. No, we put in equation 2. So we find dy by dt from here. 6 plus e to the power of 6t plus C2 cos t. So therefore, from equation 2, what was the equation? Dy by dt. We can take e to the power of 6t common from here. 6c1 cos t plus minus c1 sin t plus c2 cos t. Dy by dt minus 2x minus 5y. Y is this? C that is equal to 0. So that means 2x is equal to e to the power of 6t six sin cos t plus 6. Here 6 sin cos t minus 5 c1 cos t. So that means simply plus 6 c2 sin t minus 5 c2 minus c1 sin t plus c2 cos t. Yes. So that this implies x is equal to c1 cos t plus c2 cos t. That means c1 plus c2 by 2. So we can write, say, c3 e to the power of 6t cos t. And from here, C and C4 is equal to C2 minus C1. So these are the solutions. So y is equal to this. Say this is your 6. Six are the solutions. So we could have eliminated y also at the beginning. Then we will get an equation in the form a differential equation of involving x and t. Then you solve this, then putting in the given equation. So this is one method we have done. Other methods we will be doing in the next class. Is there any doubt?
Ma'am, this kind of answer given in the practice problem.
I will be giving.
Thank
I will
you.
give you practice problems.
Answer, ma'am.
Okay.
Ma'am, answer that the practice problem, is it somewhere available? Then we can check the answers when we are doing it by our ourselves.
I have given the answers for the practice problems. I have uploaded.
Okay, ma'am.
Yes,
I have already uploaded. Have you seen?
No, ma'am.
I have given practice problems only for one chapter. Next, I will be preparing practice problems for method of variation of parameters.
Ma'am, how
Then-
many practice problems have you uploaded till now?
20 or 22. Only once I have given.
Yes, ma'am, that I have done.
22, and then after that I have given answers also. Uploaded answers.
Yes, ma'am.
Okay. So for method of variation of parameters, I just started last week. I had not done examples. So I will be giving you practice problems. Okay.
Yes, ma'am.
So this much for today.
Madam, please share.
Yes.
Thank you, ma'am.
Yes.
Thank you, ma'am.
Share this slide.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
ma'am.